Alright guys, so today we're going to start talking about what a function is. So first things first is we're going to go through and we are going to go ahead and graph these points. I want to pick a color that, stands out a little bit. So I have -1, 2, so I'm going to start at 0, 0, go to the left one, up 2. So there's my first dot. That's this guy. Next, I'm going to go, again, starting at 0, 0, go to the right 3, 1, 2, 3, and up 6. 2, 3, 4, 5, 6. Erase that little meh. That's the second guy. Okay, I'm going to start back at 0, 0, go to the left 5, and then down 4. 2, 3, 4, 5, 3, 4. Again, start back at 0, 0, go to the right 3, and up 2. 2, 3, 1, 2. Okay, so first steps first is we graphed all of our points. Remember, we go x, comma, y. X is left, right. I'm going to put that here, comma, and y is up, down. All right, next we're asked to list the domain. The domain is x values. Oh, come on. There you go. So looking at my list, I'm going to, in mathematical order, meaning from smallest to biggest, go ahead and list any x values that I see. And if I repeat any of them, that's not what I'm trying to do. If I repeat any of them, I don't write them a second time. I only write them once. So I see I have -1, 3, -5, and 3. Well, I guess -5 is my smallest, so I'm going to write that first. Next comes -1. And then lastly 3. Now if you notice, I use 3 twice, but I'm only going to write it once. Alright, if the domain is my x values, then the range is my y values. I cannot write today. La, 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 la. Again, we're only going to write them once, so even if they're there multiple times, just one time. And also, we're going to write them smallest to biggest. So I have 2, 6, -4, and 2. So of those, my -4 is the smallest. Next comes 2, but even though I have 2 of them, I'm only going to write it once. And lastly, my 6. In this one, we're asked to find the domain and range based on the graph already. So let's go ahead and identify what my different points are. Let's talk about this guy over here. So we're going to start at 0, 0. And we're going to count left. So we have 1, 2, 3. So my x here is a -3. And my y value is up 2. So that point is -3, 2. And when I do this, I always like to go left to right, because just like when you're reading a sentence in math, you read a graph left to right. So that was my most left guy. Now I've got one down here, which is -1, comma, 1, 2, 3, 4, 5, 6, 7, 8, -8. Did I miss one? 1, 2, 3, 4, 5, 6, 7, -7. Can't count today. Sorry. Next, okay, we did this guy. Next, we come up to this guy. So I'm 1, 2, 3, so a positive 3. Up, 1, 2, 3. So that's 3, 3. And then my last point is 1, 2, 3, 4, 5, 6. Negative 1. So again, all we've done so far is identify the points. From this, we're going to go ahead and list the domain and the range, but one step at a time. Remember, the domain deals with my x values, so I'm going to take all of my x values and put them in numerical order. I have negative 3. Where am I at? Mouse, where are you? Here. I have negative 3, negative 1, 3, and 6. And I said them in numerical order. So how I said them is how I'm going to write them. My range then is my y values. So let's take a look. I've got 2, negative 7, 3, and negative 1. Well, that's not the order I want to write them in because 2 is clearly bigger than negative 7, and I don't want to put the 2 first. Makes no sense. So I have negative 7, negative 1, 2, and 3. Not too bad there. Okay, next we're going to go ahead and make a mapping diagram for the relation. So again, anything that is domain, which is my x values, will go in the first circle. And anything that is a range will go in the second one, which is my y values. There's a u there. It's connected to the e there. All right, so again, we want to not double anything. So if I see the same value twice, either in x's or y's, we're only going to write it once. And again, we want to go smallest to biggest. So I've got a negative 1, a 3, a negative 5, and 3. All right, so what's my smallest value? Negative 5. Then I have a negative 1. And lastly, I have a 3. Because remember, even though we have 2 of them, we're only going to talk about it once. Same thing here. In my range, we're going to go ahead and make them in numerical order. So I have 2, 6, negative 10, and 2. So negative 10 comes first. 2, and 6. And then, hold on, we're not going to that second one yet. When we make a mapping diagram, that means I'm going to take my x values and show which ones go with which y values. So for example, my first point of negative 5 to negative 10, when I plug in negative 5, my answer is negative 10. When I plug in negative 1, my answer is 2. When I plug in 3, my answer is 6 and 2. So this is why we want to only write each number once. We want to see which ones have repeats, not based on simply writing them twice, but writing them only once to see what happens, because it's going to tell me something in a little bit. Hint, it's going to do something with that word function. Okay, so let's try it again. Let's find all of our x values. Which one's the smallest? Good, that negative 1. Then 0. Then 1 and 2. Looking at my y's. So it looks like 2, 3, and 4. And then we're going to connect my guys together to see how it looks. So negative 1 goes to 3. 0 goes to 2. 1 goes to 3, and 2 goes to 4. Not bad. So in this next part, we're going to first go ahead and create a mapping diagram. And again, we're going to talk about what we'd want not to repeat. So we're going to start again, x and y's. So what's my smallest x value? I've got 5 and 7 and -1 and 6. So that -1 wins. Then 5 and 6 and 7. And yes, I see I wrote a little bit past my thing, but that's so you can read it clearly. Okay, which one's my smallest? Oh, my -2. Then 0. Then 2. Then 4. And we're going to go ahead and draw our lines to show which number maps to which x maps to which y. So -1 goes to 0. 5 goes to 4. 6 goes to -2. And 7 goes to 2. So the key part here is we want no, oops, not what I want, right? We do not want repeating x values. That's the idea. That's what it means to be a function. It means your x's are only used once. So taking a look at my arrows, I see that I only have one line coming from each x. So this first one is considered a function. If I scroll up a moment, notice how my first example had 2 arrows coming from it? That's considered not a function because that x value is used twice. Okay, let's try this next one. So I have 0, -1, 1, and 1. So I have -1, 0, and 1. I have 0, 2, 0, 2. Well, I just have 2 ranges in this one. -1 goes to 2. 0 goes to 0. 1 goes to 0. And 1 goes to 2. So as you can see here, since you have 2 lines coming from 1, this is not a function. And we like to talk about why. We want to explain ourselves, and I want you to know so when you come back and be like, huh? You can say that 1 was used twice. Or you can also say x values repeated. So 2 perfectly acceptable, reasonable answers. I had x values repeated. Which one? Well, 1. All right, determining whether something's a function based on a graph. This is what's called the vertical line test. So that guy up here. So a vertical line test is essentially if you can draw a vertical line through your graph and it hits more than once, so if it hits twice, 3 times, whatever, then it's not a function. And I'm going to write that up here so that you guys can have it. And we all know how awesomely amazing my handwriting is. We're not going to call this a function because then it's not necessarily a function and it contradicts itself. A vertical line hits relation. A relation is just any set of points. So, for example, any of the graphs you see below. So if the vertical line hits the graph, or in this case any relation, more than once, then it is not a function. So let's go ahead and draw some straight lines in here. And I'm going to cheat a little bit, and I'm going to actually draw lines. That's right, I'm a cheater. What can I say? All right, number 8. So this means I can draw anywhere on my graph, as long as it's vertical. Remember, vertical means up and down. Notice for this first example, this first line, it hits here and here. So I instantly know not a function. Why? Because it hit in 2 spots. Same idea on the second line I decided to draw. Again, it doesn't matter where you draw your line. As long as it hits more than once, at least once, then it's not a function. Okay, keeping that in mind, let's go ahead and draw some more lines. Does it matter where I draw these lines? No, as long as they're 100% vertical. It could be in between 2 lines. It could be exactly on a graph line. Doesn't matter. Now, if you notice, none of my lines are hitting any more than once. Even when I drew the lines in between an actual number, so like I did 2.5 or 2.25, it still only hits once. So this guy is a function. So circles, no matter how big the circle is, not a function. These guys, which are called parabolas, spelled parabola, pronounced this way. I'm going to type it so it's easier to see. So spelled parabola, pronounced come on. No, wrong number. La. So pronounced parabola, spelled parabola, those are always going to be functions, always. Circles, not functions. All right, let's take a look at this weird looking wavy thing. It's not really anything. Kind of looks like a sine graph, but it looks like it reflected. Not even. It would be a reflected, maybe cosine. Either way. Let's draw some vertical lines. What are you guys noticing? Function or not a function? Gotta swap there and there and there and there and there. Oh no, I want to write dots. Drawing dots in here. Well, I'm only seeing it hit once. So, in this case, this wave, I don't know what kind of a wave, but it's a wave, is a function. And last but not least, my sideways parabola. Oops. What do we notice here? He's hitting more than once, isn't he? I'm getting it there and there. Now, necessarily it didn't hit twice in my first point, it only hit once. But anytime after that, man, it's hitting twice. This guy is not a function. Okay, so function notation. Function notation is just changing a way we look at things. So instead of a function being y equals, you now see f of x, or some variable. Sometimes you see h of x, or g of x. What that's saying is that instead of just calling it a basic y, we're saying it's a function. So functions will be in this notation. So when it says given this function, f of x is equal to x minus 3, 5f of 5, what that's saying is anytime I see x, I'm going to replace that number. So, for example, we can do 5, 6, and 7, just because I want to see what happens. So I'm going to find f of 5, because that's what it asked me at least once. And so you see how instead of x here, I have 5? That means that every time I see x, I'm going to write 5. And I like to put it in parentheses because we don't know what's going on, what else is going on with it. So anytime I see x, I'm going to instantly think parentheses. So I have 5 minus 3, which is 2. So whenever I plug in or input 5, my answer or my output will be 2. All right, let's try f of 6 now. So where I see x, I'm going to write 6. Since nothing else is going on here, I don't have times anything divided by anything. I can go ahead and drop the parentheses. So then I have 6 minus 3, which is 3. So when I input, there it is. So when I input 6, or when I plug in 6, I get 3. I'm going to do that last one off here to the side. So f of 7 is 7 minus 3, which is 4. Okay, so we're asked to make a following table for this function. And I have 1, 2, 3, and 4. So 4 is my biggest, then 3, then 2, then 1. So in all these first ones are going to be my value for typically x, but what's my variable in this case? It's not x, it's n. So me being, oh yeah, it's always x. It's not x. Wasn't even looking, just started talking before I looked. In the middle is what it's going to look like when I plug it in. And then the output is going to be my f of n. So that's going to be what it looks like. Okay, so I'm going to try really hard to write small in this one. I might end up typing it so you can see how I want what I'm saying as I go. So I'm going to plug in 1 every time I see n, because that's my first value. So I have -2 times 1 squared. That's not very good squared, is it? Plus 7. Now we know with my order of operations, we have to do our exponents first. So 2 squared, 1 squared. So 1 times 1, because it's the same thing twice, is 1. So then I have -2 times 1 plus 7. Well, -2 times 1 is just -2. So then I have -2 plus 7, which will give me 5. So when I plug in n, in this case n is 1, my answer will be 5. Okay, let's do 2 now. So I have -2 times 2 squared plus 7. 2 times 2 is 4. So I have -2 times 4 plus 7. Well, -2 times 4 is -8. And negative 8 plus 7 is a negative 1. All right, we got negative 2 times 3 squared. It's a very terrible 3. Three squared is 3 times 3, which is 9. So I have negative 2 times 9 plus 7. Negative 2 times 9 is negative 18. Negative 18 plus 7 is a negative 11. Next one is I have negative 2 times 4 squared plus 7. Four times 4 is 16. So I have negative 2 times 16 plus 7. Sorry, guys. Negative 2 times 16 gives me negative 32. Negative 32 plus 7 gives me negative 25. So, taking a look at what we just did here, I want you to fill out this table on your own. So I want you to pause the video, fill it out, and then come check your answers. Is that what you guys got? Awesome. Okay, let's keep going. Water. All right, so we're finding the range. Well, what did we say range was? What's list of values? X's or Y's? Good. We should know that range means Y's. So we're going to find the Y values. All right, so we're given this function because it tells me it's a function, and it asks me to find the range given these domain values. That means domain is the x value, so I'm going to plug these x values into my function. So I have negative 3 times negative 3 plus 5. Negative 3 times negative 3 gives me 9 plus 5, which is 14. So one of my values is 14. Next, I'm asked to plug in positive 1. So I have negative 3 times 1, which is negative 3 plus 5. Negative 3 plus 5 is 2. Next, I have negative 3 times 4 plus 5. Negative 3 times 4 is negative 12. And then negative 12 plus 5 is a negative 7. So the range for this set of 3 domain values is negative 7, 2, and 14. All right, let's go ahead and take a look at this one together. So same idea. We're asked to find the range given the domain. So I'm going to plug in negative 2. So I have negative 2 quantities squared. Because I always put my parentheses. It's going to be really hard to do this. Let me do this really quick. I'm going to blow this up really, really big. The reason being is I want to put parentheses as best I can just around the variable. So that variable is squared. So the little 2 is outside my parentheses. So I have negative 2 squared plus 1. So negative 2 times negative 2 is positive 4. And 4 plus 1 is 5. Next is I have 0. 0 times 0 is 0. Plus 1 gives me 1. Next I have 5 squared. So 5 times 5 is 25. Plus 1 more is 26. So my range for this set of domain values is 1, 5, and 26. Okay, that's all I got for you today. See you tomorrow.